The name of our topic is the organic synthesis via enolate. In the introduction, we have studied what is meant by active methylene compound. We have studied what is meant by active methylene group. Okay, now in this topic, we are going to discuss two active methylene compound in detail. One is the acetoacetic ester and second is the diethyl malonate. Now let us discuss about the first active methylene compound. याचा आपण डिटेल डिस्कशन करणार आहोत. Acetoacetic ester, or it is also known as ethyl acetoacetate. The name of compound is ethyl acetoacetate किंवा याला आपण acetoacetic ester असे म्हटलेलं आहे. This is the methylene group. From one side there is a COCH3 means keto group. From another side there is a ester group C double bond O OC2H5, and thus here methylene group is attached from one side by keto group and from another side by ester group, means there are two electron withdrawing group. Here methylene group is attached from one side by keto, means it is electron withdrawing group, and from another side by ester, and ester is also electron withdrawing group. And thus that methylene group is active in nature, and that compound is a active methylene compound. This compound is active methylene compound because it having two electron withdrawing group from both sides. Now let us see preparation of this particular compound, preparation of acetoacetic ester. Okay, now we are going to discuss that compound in detail. याचा आपल्याला डिटेल डिस्कशन करायचं आहे. First introduction, then how this active methylene compound is prepared in laboratory, then next about the acidic nature of hydrogen, and also about the synthetic applications of this particular compound. Now let us see first about the preparation of this particular active methylene compound, and that method is called Claisen condensation. That preparation method is also known as Claisen condensation. We are using a very simple starting material for this reaction. Now what is the name of this starting material? What is the name of this? Okay, this is example of ester. The name of compound is ethyl acetate. Now ethyl acetate on reaction with sodium ethoxide followed by acid hydrolysis, means we are carrying out reaction of ethyl acetate with sodium ethoxide. Sodium ethoxide is example of strong base. It is example of strong base followed by acid hydrolysis. Now in this reaction, two molecules of ethyl acetate participate, and therefore I have written two molecules of ethyl acetate. Now actually how the reaction takes place, that two molecules of ethyl acetate undergo condensation. Here OC2H5, this OC2H5 and this one alpha hydrogen atom, यामधला एक alpha hydrogen atom, it forms C2H5OH. There is a formation of C2H5OH. Okay, then that carbonyl group, this C double bond O group, directly attached to that CH2. इथल्या CH2 ला attach होतो. This carbonyl group directly attached to the CH2, and there is a formation of our expected product, that is acetoacetic ester. There is formation of acetoacetic ester, or this compound is also known as ethyl acetoacetate. This is simple condensation, and here byproduct is the ethyl alcohol. Okay, and this reaction is called Claisen condensation. Okay, actually what is meant by Claisen condensation? Generally this reaction is shown by esters which having alpha hydrogen atom. When ester having alpha hydrogen atom created with the strong base undergo condensation to corresponding keto ester, and that reaction is called Claisen condensation, and this reaction is used for the preparation of acetoacetic ester. Acetoacetic ester is the example of active methylene compound. How this compound is prepared in laboratory? This compound is prepared in laboratory by using ethyl acetate. When ethyl acetate is created with the strong base like sodium ethoxide, it undergo condensation. Two molecules of ethyl acetate participate in the reaction, and there is a formation of acetoacetic ester. This is very simple organic reaction, but very interesting reaction, and the name of this particular reaction is a Claisen condensation. Now let us see mechanism of this reaction. We will see mechanism. Mechanism means actually how that reaction occurs. This is our ethyl acetate starting material. Okay, in ethyl acetate, I have shown one alpha hydrogen atom separately. When that ethyl acetate comes in contact with strong base, we are using sodium ethoxide. Okay, now what happens here? That strong base, that ethoxide ion takes that alpha hydrogen atom. It abstracts that alpha hydrogen atom, means that C2H5O minus and that hydrogen, it forms ethyl alcohol. Now this bond undergo breaking and this electron pair goes towards carbon and carbon acquires negative charge. Okay, here that hydrogen atom and that ethoxide ion, it forms C2H5OH, that is ethyl alcohol. While this bond undergo breaking, this is the heterolytic breaking. That electron pair goes towards carbon, it acquires negative charge and there is a formation of negatively charged carbon species, and we know that if any carbon having negative charge, then that species is called carbanion, and thus there is a formation of carbanion intermediate. Okay, this is the first step. This is the first step. In first step, ethoxide ion base takes one alpha hydrogen atom from the ethyl acetate and we get the carbanion. Now let us see second step. Okay, this is our carbanion which is already formed during the first step. Now this carbanion further attack on the another molecule of ethyl acetate. Suppose this is the second molecule of ethyl acetate. Now what happens here? Carbanion having negative charge, it acts as a nucleophile, and this nucleophile, this carbanion attack on the carbonyl carbon. It attack on the ester, means there is a formation of new bond between this CH2 and this carbon. म्हणजे इथला कार्बन आणि CH2 यामध्ये नवीन बॉन्डचं फॉर्मेशन होतं. But during this formation, this pi bond, because to maintain the valency, the pi bond between carbon and oxygen undergo breaking, and this electron pair goes towards oxygen, it acquires negative charge. म्हणजे यामध्ये एक पाई बॉन्ड ब्रेक होतो, ऑक्सिजन वरती निगेटिव्ह चार्ज येतो, while there is a formation of new bond between these two carbon. म्हणजे इथला CH2 आणि या कार्बन मध्ये नवीन बॉन्डचं फॉर्मेशन होतं. ओके, दिस इज द न्यू बॉन्ड बिटवीन कार्बन अँड CH2. कार्बन आणि CH2 च्या मध्ये या नवीन बॉन्डचं फॉर्मेशन होतं, while oxygen acquires negative charge and there is formation of alkoxide ion. Thus we get the alkoxide ion, and this is the second step. Actually, we are discussing about the mechanism of Claisen condensation. What is the Claisen condensation? When ethyl acetate is treated with the strong base like sodium ethoxide, we get the acetoacetic ester, and that reaction is called Claisen condensation. Okay, in first step, what happens here? In first step, that ethoxide ion, that base abstract one alpha hydrogen atom, means there is a heterolytic bond breaking, and this electron pair goes towards carbon, hence it acquires negative charge, while there is a C2H5OH ethyl alcohol as a byproduct. Now this carbanion further attack on the another molecule of ester, it attack on the another molecule of ethyl acetate, and there is the formation of this new bond, while carbon oxygen acquires negative charge, we get the alkoxide ion. Now let us see the third step. Okay, this is our alkoxide ion. Now this alkoxide ion, what happens? There is a negative charge, means electron pair. Now this electron pair form a pi bond between carbon and oxygen. Therefore, to maintain the valency, the bond between ethoxide ion, this is ethoxide group, this bond undergo breaking and electron pair goes towards oxygen. मग इथून काय बाहेर पडेल? C2H5O minus ethoxide ion. There is a loss of ethoxide ion, and this ethoxide ion is the best living group, and therefore this bond is easily undergo breaking. या बॉन्डचं easily breaking होतं, आणि इथं pi bondचं, here this electron pair form a pi bond between carbon and oxygen. We get the CH3 C double bond O, CH2 C double bond O, C2H5O, and this is nothing but our ethyl acetoacetate. And thus we have studied preparation of that acetoacetic ester. We also studied mechanism of this particular reaction. Now let us see next point. यामधला पुढचा point आपण बघूया. Acidity of methylene hydrogen. Actually, we will see why the hydrogen atoms of methylene group are acidic in nature. we will see why that methylene group of ethyl acetoacetate is active in nature. Okay, this is our compound CH3 C double bond O, CH2 C double bond O, OC2H5O. This is our ethyl acetoacetate, our active methylene compound. तर जनरली आपण कोणाला ऍसिड असं म्हणतोय, द सबस्टन्स विच कॅन लूज H plus ion, which can donate H plus ion, is acidic in nature. Suppose that active methylene compound, suppose that ethyl acetoacetate comes in contact with base. Okay, suppose there is a sodium ethoxide. So what happens here? That ethoxide ion takes, it abstracts that hydrogen atom, means bond between carbon and hydrogen undergo breaking, and that electron pair goes towards carbon. It acquires negative charge. त्यावरती येतो negative charge, and there is a formation of corresponding intermediate. Now here that C2H5O minus and that hydrogen, there is a formation of ethyl alcohol as a byproduct. While that carbon acquires negative charge, and we get the Carbanion intermediate. We get the Carbanion intermediate. Okay, this is just Carbanion intermediate. And we know that this Carbanion intermediate is resonance stabilized. हा जो Carbanion intermediate आहे तो resonance stabilized आहे. Means this electron pair undergo delocalization. It delocalize in ketone group as well as ester group. This electron pair delocalize in both the electron withdrawing group, and it shows the resonance effect. Now let us see how this electron pair is delocalized. In first step, this electron pair form a pi bond between that two carbon. This electron pair form a pi bond between these two carbon. Therefore, next pi bond undergo breaking and electron pair goes towards oxygen. It acquires negative charge. म्हणजे इथं pi bond तयार होतो आणि ही pi bond break होतोय, and this electron pair goes towards oxygen, and we get the intermediate, and this is nothing but the enolate ion. This is nothing but the enolate ion. Okay. Now suppose this electron pair is delocalized in the ketone group. म्हणजे लेफ्ट साइडला त्याचं delocalization होत असेल तर इलेक्ट्रॉन पेअर इथं पाय बॉन्ड तयार करते, त्यामुळे इथला बॉन्ड ब्रेक होतो, इलेक्ट्रॉन पेअर ऑक्सिजन कडे जाते, and we get the this enolate ion. हा पहिला enolate ion आपल्याला मिळतो. Means that electron pair from the oxygen can be delocalized towards left or right side. It can delocalize in both the electron withdrawing group, and we get the resonating structure. We get the enolate ion. Thus, our carbanion is resonance stabilized. Our carbanion is more stable because there is a delocalization, and hence काय होतं त्यामुळं, hence that process, म्हणजे मगाशी आपण जे पाहत होतो, जर आपला ऍक्टिव्ह मिथिलीन कंपाऊंड, when our active methylene compound is treated with the base, it can easily lose hydrogen. It can easily lose hydrogen to form a stable carbanion. आणि म्हणून तिथं स्टेबल कार्बॅनियन तयार होतो. कार्बॅनियनला मी स्टेबल शब्द का वापरलेला आहे? बिकॉज दॅट कार्बॅनियन अंडरगो delocalization ड्यू टू प्रेझेन्स ऑफ इलेक्ट्रॉन withdrawing group. That electron pair delocalize in both the electron withdrawing group, and hence it become more stable. आणि जर कार्बॅनियन स्टेबल असेल तर त्याचं फॉर्मेशन इझिली होतं, म्हणजे इथिल ऍसिटोऍसिटेट ऍक्टिव्ह मिथिलीन कंपाऊंड इझिली हायड्रोजन बाहेर टाकतो, इझिली हायड्रोजन त्यामधून बाहेर पडतो, अँड वी गेट द स्टेबल कार्बॅनियन. ओके, अँड देअरफॉर दॅट हायड्रोजन्स आर ऍसिडिक इन नेचर, and therefore that methylene group is active in nature, and therefore that compound is called active methylene compound. Okay, this is the reason why that methylene hydrogens are acidic in nature, why that methylene group is active in nature, and why that compound is active methylene compound. Okay, this is just about the introduction.